SwayamPrabha. Digital India. Educated India.
Development of surfaces which are non-developable or oblique. So these are the surfaces that you cannot cut and lay down flat on a piece of, lay down flat on a plane. Alright, so we need to pursue or follow some tricks in this. Okay, so that's on development. Keep that in mind. Alright, so let's look at this sheared hexagonal pyramid. The top view is shown and so is the front view. It's kind of sheared, so what you do is you actually have your solid like this. You just kind of shear the top surface with respect to the bottom surface. Okay, that's how this solid is, and we would like to develop it. Step 1 in development, always look for true lengths, true shapes, because unless you do that, it will be difficult for you to develop any solid. Alright, so you got how many edges? 1, 2, 3, 4. 4 that you see and 2 are behind. Okay, so 1, 2, 3 and 4. So these are the edges that you see, and then 2 edges are behind these 2 edges, right? Can you identify edges in true length? If so, which ones are those? Which ones are those? Come again? 6, 5. So this is in true length because this projection is horizontal. What else? 6, 7. 6, 7. Well, that's in true length also because horizontal, horizontal. Once again, any other? 1, 8. Yeah, so you see this projection and the corresponding projection for this is horizontal over there. So you have a bunch of edges which are in true length. Okay, and if you wanna develop this, how would you want to go about this? How would you want to go about developing this surface? Well, start with the hinge line. You know that edge 1/8 is in true length. Okay, and if you kind of cut your solid, let's say at this edge, if you cut this solid at edge 1/8 and open it up perpendicular to this. Okay, this is how your vertices 1, 2, 3, 4 and 5, 6, 7, 8 will appear. They will be appearing on these corresponding projections. Right, so once again, scissor this edge, open this surface out. These vertices are going to be appearing on the respective projections. Okay, so once you have figured these projections out, start with edge 1/8. Okay, and follow the connectivity. 1/8 is connected to what? So 1 is connected to 2, 8 is connected to 7, 2 and 7 they are connected. So follow this connectivity in from both the views. From 8, what do we have? 7, and this length is the same as this length, right? And this length from 1, what do we have? 2. Okay, and this length is in true length, of course. So we got 2 here, we got 7 here. 2 and 7 are connected, and keep going forward. 2 is connected to what? 3. Okay, 2, 3, and 7 is connected to what? 6. All right, so you can figure the true lengths of 7, 6 and 2, 3. Okay, keep going forward because 6, 7 is going to be in true length. both the projections are horizontal, and so on. This is a relatively trivial example. (1,8 to 1,8). Fine? Relatively trivial example. Nothing very rocket science about this. All right. A weird looking cone. What about the? What about the what? Well, yeah. So if you want to consider this to be an open solid, just the surface, then you don't have to worry about the lids. But if you want to consider that to be, yeah. So weird looking cone, the apex is shifted, not marginally, but really in a weird fashion, and we would like to develop this. Okay. Now, is it possible for you to develop this weird looking cone the same way as you would develop a regular cone? Is it possible? Once again, is it possible for you to develop this cone the same way as you develop a regular cone? Yes? Assuming that's not possible for you to develop this surface, in a regular fashion, what do you do? You approximate the surface, and the way to approximate the surface is via triangulation. It's possible to develop the surface accurately, maybe not. So you need to go for approximate development, and the way to do that is to triangulate the surface, and this is how. Divide the base into equal number of parts, label these vertices 1 to 12, and draw generators from each of these vertices to join the apex O. Okay, so project those vertices down onto the front view. The apex over here of the cone is O. Join each of these vertices to that apex. Okay, so the surface of this weird looking cone is now approximated by a bunch of triangles on the surface of this solid, so to speak. Okay, to develop this cone now implies how you treat these triangles. Now? Yeah? All right. And the same procedure. Try to figure the true lengths or true dimensions from both of these views. So we will be needing a true length diagram, okay, to figure out the true lengths of these edges, 0, 1, 0, 2, 0, 3 up till 0, 12, and of course 1, 2, 3, 4, 5, 6, 7, 8, and so on and so forth. Now look at this segment here, 8, 9, not the arc but the segment, line segment. Would that be in true length? How about 6, 7? Would this be in true length? So in fact, all these line segments joining these vertices, they will be in true length because the corresponding projections in the front view are all horizontal. Right? Step 1, fetish. Clear. Step 2, how do we figure the true lengths of 0, 1, 0, 2, 0, 3 up till 0, 12 is what the question is. And for that, we need the true length diagram. Now, look at 0, 1 and look at the corresponding projection in the front view. Is that in true length? Look at 0, 7 and look at the corresponding projection of 0, 7 in the front view. Is that in true length? 0, 1 is in true length and 0, 7 is in true length. Okay? Well, start with a right angle triangle that I've drawn over there. To find the true lengths of the rest of these segments, what do you do? Method of rotation, right? So rotate 0, 2 to lie on the horizontal, take its projection down or measure this length, take its projection down over here, okay? Or what you could do is you could transfer this projection over here directly. And this is 0,2 in true length. Likewise, 0,3, measure this length, transfer it down here, and join vertex 3 to 0, and that will give you the true length of 0,3. And so would the same procedure for 0,4, 0,5, 0,6. Simple method of rotation. Measure these guys, transfer them onto the true length diagram. That's in true length. Okay, that's in true length. That's in true length. And that's in true length. All right? So once you have the true lengths of 0 i's, where I goes from 1 to 12, and all these other guys, you can start developing this surface. Okay? And this is how. Start with 0,7. Okay? Draw an arc with radius the same as 7,8 or 7,6, depending on which side you're developing. Okay, so if it's 7,6, so this distance is the same as this distance, and then to get this length, you need to choose what? Distance from here up till here. Yeah? 6 fixed. Number 5. With this distance, cut an arc, okay, and with 0,5, cut another arc with this point as center, 5 located, and continue. Yeah? So this is not a true development, but an approximate development. And the way we did that, the way we performed this development is through triangulation. We approximated the surface of a solid by means of a bunch of triangles, by means of a set of triangles. As simple as that. All right? And okay? Everybody with me? Everybody with me? Yes, sir. Yes, sir. Yes, sir. Better. First example of the method of triangulation. So if you remember our discussion last time on Tuesday, you go for parallel line development in case of cylinders, prisms, etc., those kinds of surfaces, solids. You go for radial line development in case of cones, pyramids, regular solids, cones, pyramids. And you go for triangulation for other complex or non-developable surfaces like in the previous example. As I said last time, they all, some way or the other, involve determination of true lengths and true shapes. Without that, you cannot do anything. This is another pretty interesting solid. The front view given, the top view given. Yeah? This cross section is circular. This cross section is rectangular or square. So this surface is actually a blend between this circular cross section and a rectangular cross section. Can you imagine this? Yes, sir. All right. A linear blend between two different shaped cross sections. How do we develop this? How do we develop this? Triangulate? No, that's manufacturing, that's not developing. You're far ahead of me. First we need to develop this, and then in your TA 201, if you get a chance to make this, then make that. Yeah? So we triangulate the surface. Okay, it's a non-developable surface. We triangulate that. And the way we do that is we divide the circular cross section into a bunch of parts. Okay, and we actually work with the 4 vertices of the square. Okay, and we join these vertices in such a way that we get triangles, okay, approximating the surfaces over here and the surfaces over here. Look at the way I'm joining the triangles now. I'm joining these vertices to get the triangles. You follow the red lines? Bunch of triangles. Okay. Easier to work with the top view. Just transfer those triangles onto the front view. Alright, so yeah, of course. I'm approximating this curve by a bunch of linear segments also. Okay. So triangles 11, 3, 4, 11, 4, 5, 5, 6, 12, 6, 7, 12, 7, 12, 9, 7, 8, 9, 1, 8, 9, 1, 9, 10, so on and so forth. They all approximate the surface. Transfer the vertices onto the front view and transfer the connectivity as well onto the front view. Okay. The trick is, or the notion is, to work with as less number of triangles as possible. Okay, but necessary enough number of triangles that would allow you to develop this surface properly. Okay, so you don't want to compromise on the shape of the surface. What do we need next? The true lengths. For that, we need the true length diagram. Notice that all these green edges, they happen to be true lengths. Yeah? How about the rest? What do you have to say about the lengths of 8, 9, 2, 10, 11, 4, 6, 12? Are they the same? Are they the same? So just, What? Same but? Yeah, of course. Well, the true lengths of these edges will be the same, won't they? The true lengths of these edges, 2, 10, 4, 11, 6, 12 and 8, 9, they would be the same. And likewise, the true lengths of 1, 10, 1, 9, 9, 7, 7, 12, 12, 5, 5, 11, 11, 3, 3, 10, they will all be the same. So we need to find the true lengths of only a set of lines, and we'll be happy with that. Nah? Alright, all greens in true lengths, that's okay. Need to determine the true lengths of edges like 1, 9, 2, 10 and 1, 8. So I'm going to be preparing my true length diagram over here. Length 9, 10 is in true length. Length 9, 10 is in true length. Yeah. To get the true length of 1, 9, I would rotate this projection of 1, 9 in the top view so that this projection becomes horizontal. And then I would project that down onto the front view. Okay. And this length 1, 9 will then be my true length. Method of rotation. As simple as that. To get the true length of 210, I would rotate 210 so that 210 becomes horizontal. So this guy here, I have rotated it about vertex 9. This guy here, I would rotate it about vertex 10. So 210 becomes horizontal. I'll take the projection down. Cell phones off, please. I'll take that projection down. And 2 is here. All right. So this guy here, that would be my true length, 210. What else am I left with? 1, 8. 1, 8 is already in true length. I don't need to worry about that. But if I still want to figure out the true length of that, I'll rotate 1, 8 about 1, take its projection down, and this is my true length 1, 8. So once I have the true lengths of all the edges of these triangles that approximate the surface, I am ready to develop the surface. Pick a compass, pick a pencil, and get started. Start with 9, 10. And of course, when you're developing, make sure that you're following the connectivity here and here, following the topology. All right? 9 is connected to what? 9 is connected to 8. 9 is connected to 1. So which triangle am I going for first? I start with 9, 10. I start with 9, 10. I'll go with 9, 1. And I'll go with 10, 1. So this triangle is something that I have now on my two-dimensional plane. Yeah? 9, 10, 9, 1, 1, 10. Okay? Which triangle now? Perhaps 1, 2, 10. Okay? So with 1 as the center, 1, 2 as the length, draw an arc. With 10 as the center, 10, 2 as the length, draw another arc, you will get a triangle. Okay? Or you could go with 1, 8, 9. 1, 8, 9 is here. Same thing. So you have vertex 9 here with this length 8, 9. With 9 as center, draw an arc. With this length 1, 8. With 1 as center, draw another arc. You'll get 8. Okay, and keep on following this procedure. We get 1 to 10. Make sure that you are following the connectivity right. 1 to 10, and then the next triangle would be 2, 3, 10, and the next one will be 3, 10, 11. Next one 3, 4, 11. And then 11, 4, 5. Keep on continuing. This is straightforward. So the challenging part for you is this true length diagram and understanding the fact that you have to approximate a non-developing surface using a set of triangles. Yeah? You cannot? But cutting out a circle is not a problem, but your question has a context. What is the context?
So this diagram is the previous is a sheared cone.
Yeah.
We approximated the number of triangles and then we find out.
Not the sheared, well, sheared cone, yes.
Same way, the circle is considered to have infinite triangles in it.
Yeah.
Is it possible to cut out a perfect circle?
Well, the accuracy of development will depend on the number of triangles you use to represent the surface. The more the number of triangles you use, the better the accuracy of this development will be.
For example, if they are asked to cut out a circle of radius 5, do we get accurate circle?
Again, so merely cutting out a circle out of a piece of paper is not a problem. Right? So if you just want to cut this circle out from a piece of paper, perfectly fine. But if you are wanting to cut this circle with reference to the entire surface around it, that's the context. Now, look at all these vertices lying on the circle. 1, 2, 3, 4, 5, 6, 7, and 8. 1, 2, 3, 4, 5, 6, 7, and 8. Okay, and then you have to, of course, have one more triangle over here, I think. Yeah. Right? So these guys, where would they lie? So if you glue this 9, 8, if you glue this 9, 8 with that 9, 8, and if you kind of close the surface, all those guys, they will be approximating a circle from this example. Yeah? So my point is, if you want, so if I understand your question correctly, if you want this part of the surface to be a precise circle, is this what you want? Is this what you want? If you want this part of the surface to be a precise circle, you will have to have more number of points approximating that circle. And then, well, I mean, you have to account for those points now by means of triangles. Those points on this circular curve over here, they have to participate in triangles. They have to be a part of the triangles. Thinking and analyzing. Ends? Well, you have lab number 13, and then you have your exam. It better not end. And even after this course, your thinking and analyzing should not end. C for M for didn't you say M for midterms, M for marks, M for money, M for what? Math. C for Chapu. This is Brahmagyan. Brahmagyan, nothing to do with TA 101, but everything to do with thinking and analyzing that I will share with you. If you want to take it, take it. If you don't want to take it, fine. C for contentment, satisfaction. One word that each and every one of you is looking for throughout your life. Yeah? Does anybody disagree? C for contentment. C for currency, money. Many of you guys think the more money you have in your pocket, the more content you are. Is that true? Louder? Not true. But still, trust me, once you're in your 4th year, you're going to be going for companies who are going to be paying you higher. Okay? Which you should not. You should be going for companies that offer you jobs of your choice. C for choice. Your choice. That's where things change. The more choices you make, the more confidence you get. C for confidence. The more choices you make, the more confidence you get in life. The more compromises you make, okay, compromises would be like without you wanting to do something, you're forced to do something, some way or the other. The more compromises you make, the less confidence you get. 2 factors which are going to be important throughout your life after you're 26 or 27, maybe later. Career, C. Your spouse, your companion, C. Your life will revolve around these 2 factors. You choose the right career, you're content. You choose the right companion, you're content. You choose the wrong career, you choose your wrong spouse or companion. C words. Children, direct source of contentment. Look at a 1-year-old, you like to hold him or hold her in your hands. Yeah? C for college. You can figure out a bunch of C words that if you cogitate about, if you think and analyze, and this is why perhaps subconsciously I named this course Think and Analyze 101. So if you think and analyze about these bunch of C words, you will see how these words might change your life later on. Keep brooding. Finally, you always say, you know, the politicians aren't good. They are doing. No, it's a democratic country. I can say whatever I want. Well, within limits. So you guys tend to censure people. You guys tend to blame people, you know, for things which are not right around you. You guys want to change. C word. You guys want to change for things to be better around you. You are the change. You take a right step forward and the world will follow you. You don't wait for the world to take the right step forward and then you follow the world. It's the other way around. You take the right step forward and the world follows. Brahmagyan. Impressed? Imbibed? Taken in? Alright, so with that said, lab number 13 is on. Your exams are on the 26th, 9 to 1. A single minute late, Doors are closed. Keep that in mind for both badges. No sharing of equipment, information, anything during the exam or in between when the badges are getting or when the badges are in transition. Anything else? Was a pleasure teaching you. And for that, thank you in advance.